Welcome to EDU World Space.
Okay, in this problem we have total internal reflection for a light within a source emitted from a liquid which travels up to the surface and internally reflects. We know the height, the depth of the source of the light in liquid, which we're going to call h, and we know that this light travels horizontally some distance d before it hits the surface of the liquid and internally reflects. So by definition, for internal reflection, uh, the second angle, theta 2, the refracted slash reflected angle is always 90 degrees. That's always the case for internal reflection, total internal reflection. So we're going to apply Snell's law for refraction, which will state that n, we'll just say n liquid times sine of the incident angle, theta 1, is equal to n of air times sine of theta 2. We know n of air is always 1, and we know sine of theta 2 is going to be sine of 90 degrees, which is 1. So the right-hand side of this is 1, and we have n sine theta 1 on the other side. And we need to figure out what theta 1 is. So we don't have that yet. We can't use it. But what we can do is we can use the trig of the situation because we have two distances, h and d. We can find theta 1 using some trig. In particular, tan might be useful. So leaving this aside for now, let's take a look at something else. We'll use trig to find theta 1. Tan of theta 1 is simply d over L, opposite over adjacent. Thus, theta 1 is simply arctan of 7.6 centimeters over 8 centimeters, which will give us 43.53 degrees. Once we have that angle, we can turn to what we're more interested in. Back to the Snell's law, which we had incomplete. So n of our liquid times sine of theta 1 is simply equal to 1. That's true. Which means that sine of theta 1 max, at a maximum, this angle is going to be 1 over n. Okay? So it must be true that to get some total internal reflection, our sine of theta 1 must be greater than or equal to sine of theta 1 max, which is equal to 1 over n for our liquid. Thus, actually plugging in our theta 1 must be the case that sine 43.53 degrees, which equals 0.6887, has to be greater than or equal to 1 over n. So expressing this inequality in terms of the n more explicitly, it must be the case that the index of refraction for the liquid has to be greater than or equal to about 1.5. And that's really the big result here.